Welcome to an eye-opening journey into the world of rare and unconventional energy sources. Throughout history, humanity has been driven by a thirst for energy, fueling our civilizations and propelling us into the future. We've come a long way from burning wood to harnessing the power of the atom. But our quest for new and innovative energy sources is far from over. Today, we'll explore some of the most mysterious and potentially revolutionary forms of energy that science has to offer. From the quantum realm to the vast expanse of the cosmos, we'll delve into the depths of these enigmatic energy sources, examining their potential to reshape our world. Fasten your seatbelts, fellow explorers, as we embark on a mind-bending adventure into the frontiers of energy. Our first stop takes us deep into the realm of quantum mechanics, where we encounter the mind-boggling concept of zero-point energy. Imagine a state of absolute emptiness, a vacuum devoid of matter and energy as we know it. Now, picture this. Even in this seemingly empty space, there exists a sea of fluctuating energy fields, a constant dance of quantum particles popping in and out of existence. This, my friends, is the quantum vacuum, and it's teeming with zero-point energy. This concept arises from one of the fundamental principles of quantum mechanics, the Heisenberg uncertainty principle. This principle states that you can never simultaneously know both the position and momentum of a particle with perfect accuracy. This inherent uncertainty leads to a minimum energy level, even in a vacuum, hence the term zero-point energy. While the existence of zero-point energy is predicted by quantum mechanics, harnessing it is a whole other ballgame. Scientists and engineers are exploring various theoretical approaches to tap into this potential wellspring of energy. One such avenue is through the Casimir effect. This effect, experimentally verified, demonstrates that two uncharged, perfectly conducting plates placed very close together in a vacuum experience an attractive force. Now imagine if we could somehow manipulate the Casimir effect or other quantum phenomena to extract energy from the vacuum. The implications are staggering. Prepare yourselves, fellow cosmic explorers, as we venture into the depths of space to unravel the mysteries of dark energy, one of the most profound enigmas in modern cosmology. Imagine this. The universe, instead of slowing down due to gravity, is expanding at an accelerating rate. This baffling observation has puzzled astronomers and physicists for decades. The culprit behind this cosmic acceleration? Dark energy, a mysterious force that makes up a whopping 68% of the universe's total energy density. Unlike ordinary matter and energy, which we can observe directly, dark energy remains elusive, its true nature shrouded in mystery. We know it's there because its effects are imprinted on the fabric of space-time itself. Observations of distant supernovae acting as cosmic lighthouses reveal that the expansion of the universe has been speeding up for billions of years. Some theories propose that dark energy is a property of space itself, a cosmological constant that Einstein first introduced in his theory of general relativity. Others suggest that it could be a new type of energy field, quintessence, with properties that vary over time and space. Now, imagine if we could somehow harness this enigmatic force. The possibilities boggle the mind. However, our current understanding of dark energy is rudimentary at best. Hold on tight, fellow adventurers, as we delve into the realm of torsion fields, a concept at the fringes of mainstream physics. Imagine a universe where space-time is not only curved by gravity, but also twisted by particles' spin. Proponents believe this spin generates torsion fields, influencing particles and space-time. Despite decades of research, torsion fields lack widespread acceptance due to limited experimental evidence. Yet some researchers envision harnessing these fields for energy and communication. These ideas remain speculative and debated within the scientific community. Chapter 4: Orgone Energy, delving into the realm of life force. Our quest for rare energy forms now leads us to orgone energy, a concept both lauded and dismissed. Wilhelm Reich, a controversial psychoanalyst, described orgone as a primordial cosmic energy. He believed it was a real, measurable force, distinct from other known energies. Reich claimed it could treat illnesses and enhance well-being. He built devices called orgone accumulators for therapeutic use. However, his theories faced widespread skepticism. Critics argue there is no scientific basis for orgone energy. Despite this, orgone energy has its proponents. They cite anecdotal evidence and personal experiences. It's important to approach such claims with skepticism. Until convincing evidence emerges, orgone energy remains unproven. Chapter 5. Cold Fusion, the elusive dream of tabletop nuclear energy. Our journey into the world of rare energy forms now takes us to the realm of cold fusion, a concept that has sparked both excitement and controversy within the scientific community. Imagine a world where nuclear fusion, the process that powers the stars, could be achieved not in massive, expensive reactors, but at room temperature in a simple tabletop device. This, my friends, is the tantalizing promise of cold fusion, also known as low-energy nuclear reactions, or LENR. The most well-known claim of cold fusion came in 1989 when two electrochemists, Martin Fleischmann and Stanley Pons, announced that they had achieved fusion in a simple electrolytic cell using palladium electrodes and heavy water, which is water containing deuterium, a heavier isotope of hydrogen. Their announcement sent shockwaves through the scientific world, raising hopes for a revolutionary new energy source. However, the excitement was short-lived. Attempts to replicate Fleischmann and Pons's experiment by other researchers met with mixed results, and the scientific community remained skeptical. Despite the skepticism, research into cold fusion continues in some quarters, albeit on a much smaller scale than in the heady days following Fleischmann and Pons' announcement. Chapter 6. Piezoelectric energy, harnessing the power of pressure. Our exploration of rare energy forms now takes us to the fascinating world of piezoelectricity, where mechanical energy is transformed into electrical energy and vice versa. Imagine a material that generates an electrical voltage when subjected to mechanical stress, like squeezing or stretching. That, my friends, is the essence of piezoelectricity. The word piezo comes from the Greek word for press, and it aptly describes the phenomenon. Certain materials like quartz crystals, ceramics, and even some polymers exhibit this remarkable property. When these materials are compressed or stretched, the arrangement of their atoms is distorted, creating an electrical dipole moment, which in turn generates a voltage. The piezoelectric effect has been known for over a century and has found numerous applications in our everyday lives. It's used in quartz watches to keep time, in microphones to convert sound waves into electrical signals, and in gaslighters to create a spark. But what if we could harness this effect on a larger scale to generate usable amounts of energy? That's the goal of researchers exploring piezoelectric energy harvesting. They envision embedding piezoelectric materials in roads, sidewalks, and even shoes, where they would generate electricity from vibrations and pressure. Chapter 7. Bioenergy from rare organisms, nature's hidden energy factories. Our final stop on this journey into the world of rare energy forms takes us to the fascinating realm of bioenergy, where we explore the remarkable ability of certain organisms to produce energy from unusual sources. Imagine harnessing the power of microbes that thrive in extreme environments like hot springs or deep sea vents, or tapping into the unique metabolic pathways of rare plants that have evolved to survive in harsh conditions. This, my friends, is the promise of bioenergy from rare organisms. These organisms, often found in extreme environments, have developed unique metabolic pathways to survive and thrive. Some bacteria, for instance, can convert waste products into methane, a valuable biogas. Others can generate electricity from sunlight or even break down pollutants, cleaning up the environment while producing energy. By understanding and harnessing these organisms' biological processes, scientists hope to develop sustainable and efficient methods for producing bioenergy. While the field of bioenergy from rare organisms is still in its early stages, it holds tremendous potential for developing clean, renewable energy sources. Thank you for joining us on this fascinating exploration of rare energy forms. From the mind-bending realm of quantum mechanics to the depths of space and the hidden wonders of the microbial world, we've journeyed far and wide in search of new and innovative ways to power our future. While some of these energy sources remain speculative and require further research and development, others, like piezoelectric energy and bioenergy, are already making their mark. The quest for clean, sustainable energy is one of the greatest challenges and opportunities of our time. By exploring the full spectrum of energy sources, both conventional and unconventional, we can weave a tapestry of possibilities for a brighter and more sustainable future. Stay curious and keep exploring the mysteries of our universe. Don't forget to like, share and subscribe for more captivating content.